to NASA Launchpad. I'm your host, Alicia Sears. So, you all have heard of Mars, the red planet, our next door neighbor, if you will. This planet is full of mysteries. Some scientists even believe that Mars used to be a lot like Earth billions of years ago. It once had rivers and lakes and possibly even supported some form of life. But how do you test ideas like those on a planet that is millions of kilometers away? Well, where do scientists do their best research work here on Earth? In the lab, right? So why not send a laboratory to Mars? And that's just what NASA has planned. The groundbreaking Mars Science Laboratory is also known as the Curiosity rover. And it's going to take science to the surface of the red planet like nothing we've ever seen before on Mars or any other planet beyond Earth. Let's talk with Ashwin Vasavada, Deputy Project Scientist for MSL, to get a little more insight into this enormous mission.
The primary scientific goal of the Curiosity rover is to find evidence for a habitable environment on the surface of Mars. We have lots of data from orbiters. We have pictures showing places that look like water was flowing in the past. Our landing sites that we're choosing from all contain that sort of mineralogical and geological evidence for habitable environment. And then we're going to put a rover on the ground to really confirm that that was the case. We're not necessarily looking for life, but we're looking for places on Mars that we can sort of confirm that this is a friendly environment to life, whether it ever took hold there or not. So this rover is designed to drive multiple miles around a specific landing site that we determined from orbit looks like one of these potentially habitable environments. And then it's designed to take lots of images of that area, but most importantly, to sample the rocks and soil, to directly look for evidence that water existed in the past, that certain chemicals were there that life uses, and then also to look for the hazards to life.
Curiosity will carry the most advanced payload of scientific gear ever used on Mars' surface. A payload more than 10 times as massive as those of earlier Mars rovers. To carry a big payload, NASA's going to need a big rover. And the rover is the size of a small car. But landing something that big on another planet has never been done before.
We have a giant rover. It's a 2,000-pound rover. It's the biggest thing we've ever sent to another planetary surface. And just landing that on a planet with an atmosphere is one of the biggest challenges.
When the spacecraft carrying Curiosity arrives at Mars, it will begin its descent into the Martian atmosphere, and the craft will be guided by small rockets as it makes its way toward the surface. A huge parachute will then deploy to further slow the speed of the descending spacecraft. The spacecraft will open, and the rover will eventually separate from its final delivery system, the Sky Crane. Like a crane on Earth, the Sky Crane touchdown system will lower MSL until it achieves a soft landing on the surface. The best part of all of this, we'll get to see it.
One of the more exciting things we're doing is we're actually taking a movie as we're descending the final few miles in the atmosphere. This is mostly just for the public to share this experience of arriving and landing on a planetary surface.
I'll definitely be tuning in to watch that. Since Curiosity is carrying so many instruments, there's going to be some really exciting science taking place.
So the MSL rover is more complex than anything, mostly because it has 10 scientific instruments. And not only that, but it has also a lot of equipment to enable the science to be done. We had designed a system that could drill into solid rock and turn that rock into powder that you then could feed to a chemistry laboratory, which is located inside the rover. Another really clever instrument that we have on this rover is a way of remotely detecting the chemistry of the rocks and soils around the rover. And this is an instrument that's mounted up on the mast near the cameras. It actually is a telescope that fires a laser, and so we can fire a laser at a rock and soil target up to about 20 feet away from the rover. And then we image the color of that spark, and the color actually tells us what the chemistry is, what chemical elements are present, and then from that we can sort of put together a picture of what minerals are present. And so this is kind of neat. We carry a little laser ray gun with us and can zap things and figure out what's around us.
And MSL looks to be gearing up for the long haul.
Yeah, the MSL mission is designed to last 2 years on the Martian surface. We think in order to really characterize this landing area, we need to take several dozen samples. And that's just going to take the full 2 years to drive around and to put the samples through our sample processing system, analyze it in our instruments, and send that data back. The last set of rovers were designed for 90 days, but they've now lasted 6 years. Now we have to beat the record set by the previous rovers. So we're designed for 2 years, and we hope we last, much more than that.
So what will MSL teach us about the chemistry and geology of Mars? What new questions will scientists have after they learn this new information? What new instruments are engineers going to need to answer the new round of questions? Curiosity might just be the best name for this new rover after all. That's it for this episode. I'm Alicia Sears. Catch you next time on NASA Launchpad.